Hi, today we're going to be preparing the production files for the main power supply PCB on the ringlight project. Now this PCB is going to be assembled at JLCPCB, so that means we've got to prepare the bill of materials file for the surface mount components and then also the pick and place file. Now I think I've been through all of the comments on the past few videos, and I think everything that anyone has mentioned that is worthwhile including has been modified onto the PCB. There was a comment about whether there's enough vias where the high current tracers go through the layers, and there are actually additional vias. It's just that when you place them on Proteus, they show up slightly differently to the standard vias that are placed when you drop through layers. So there are additional pads, and they do connect through multiple times where they go through different layers. So I don't think we've got any problems there. And I think that was really the only thing that was mentioned this time on the power supply PCB. There was one excellent suggestion on the LED board, which I've now implemented and uploaded to the website. So that is to remove the solder mask where the heatsink is going to be placed. So there should be bare copper on the other side of the board. So first of all, we need to prepare the Gerber files. So I think that's everything that we need. It's in metric. For some reason, Proteus always defaults to imperial, and we should be able to produce that file. And that's now done. Next, we need to export the pick and place file, and so we'll put that in the outputs for JLCPCB, and that's just the pick and place file in the Proteus format. We do have to modify this to be suitable for JLCPCB. And then finally we've got the bill of materials, which is actually coming from the schematic. So here we can go to bill of materials, and we want the JLC PCB output. Now this is a custom output that I have created. However, instructions on how to create this file are actually on the JLC PCB website. So I'll put a link to that in the description down below. And what it does is puts it basically in the format that JLC PCB wants. So we can save that. Again, we'll put it in the outputs for JLC PCB and click save. And then we need to start editing those files. Now, if we go to the JLC PCB website, it shows you the format that it wants the pick and place file. So we want the reference designator first, then the X and Y positions in millimeters, the layer, either top or bottom, and then the rotation. Now, it does have to be in this format, otherwise it just completely messes everything up when you try and place the order. You can see everything's all in the wrong place. So you do need to get this correct. And if you look at how Proteus outputs this, you can see it's not in the correct format. And even things like this, where it says the layer as top, that doesn't work. It has to be with a T like this, and it does expect those headings as well at the top. So we need to do a bit of conversion. Also, the X and Y positions are in imperial units, so we need to convert those into millimeters. Now, I should really write a script to do this because I do place these orders quite often. But what I tend to do is just use one of my previous spreadsheets for the formulas. So I'm just going to dig that out, and then we'll have a look at what we're actually doing. So here is a spreadsheet which I used for the RGB touch controller, and you can see it starts off looking the same, and then I've added some extra columns here. So first of all, we've got the conversion into metric, then we reduce the number of decimal places. They're only expecting 3 decimal places here, and then we concatenate the millimeters onto the end here. And then basically what I end up doing is copying these columns into another sheet in the spreadsheet that's in the correct format. So we've got our extra columns now. We copied across the formulas for each of these and ended up with the positions in X and Y that are in the format that JLC PCB expect. So what we can do now is put these into the sheet that's going to become the output, and we should be able to just copy these across directly. So first of all, we've got the reference designator. Now the layer, they're all on the top here, so we may as well just create that ourselves. Rotation, and we may have to fiddle around with the rotation value because it depends on how it was created in the library, but for now we'll just copy that across. Then finally the X and Y values. Now we do need to do a paste special on these so that it doesn't try and transpose anything between the sheets. We just want the text values. And similarly for Y. There we go. So that's the pick and place file sorted. We'll save that, and then we'll export just this one sheet as an Excel file. Next, we need to create the bill of materials file, and it needs to be in this format. So we've got something called comment, which is the actual component value, the reference designator, the footprint, and then as an optional column, to save time later, we put all of the part numbers in there for the part. So we do need to rearrange the output from Proteus slightly. We need to get rid of this column first. Then we need to move across the component values. And then we've got the reference designator, and then finally the footprint. So that actually needs to be named footprint here. Designator and comment. And then finally we want the LCSC part number. So what we need to do now is then go on the JLCPCB website and start searching for the parts and making sure that they're in stock, and then copying across the part number into the bill of materials file. Now, when I was drawing up this schematic, I was searching for parts at the same time in the JLCPCB library. So for example, I put a part number here for this capacitor so I don't have to search for it at a later stage. What we'll do is just check that that is still there in the parts library, because sometimes they do go out of stock, but they've got 2,938 of those. And what we need is this line here, the LCSC part number. So we'll copy that and we'll put it into the spreadsheet. So that's all of our surface mount parts. We just need to separately order the slide switch, the potentiometer, and also the power connector, but everything else is there, so we can export that again as an Excel file. And now we should be able to upload these to the JLCPCB website. So let's start uploading the files. We go to quote now and add the Gerber file, and it's this file here. And so that's now uploaded. You can see that it hasn't taken out that center section, although the routed out area is shown. So we're going to add some notes to the order further down. Now I'm actually going to order 20 of these, and if anyone wants one of these boards, then if you can cover the postage, then basically I'll send some of these out. So we've got one different design, single PCB, PCB thickness of 1.6 millimeters is fine. We can only choose green because we're going to be doing the assembly service. And we don't need the gold plating on this because all of the parts are going to be soldered on anyway. We'll remove the order number. And then we've got some advanced options here. So it says confirm production file. I think this gives us the opportunity for JLCPCB to show us what they're actually going to make, instead of like last time getting those PCBs and then finding out that it doesn't have the hole cut in the middle. So we will do that as an option. And then we'll also add in a comment just to check that it's going to router out that center section of the PCB. And that should be enough just to explain things. Hopefully, if there's any problems, they should get back to us. Now, we do want to do the SMT assembly, so we'll click on that. And we're going to assemble the top side. In fact, there's no components whatsoever on the bottom side anyway. Tooling holes can be added by JLCPCB, that's fine. And there we go. So I think that's all we need. Let's just check all the options once again. And that all looks correct. So $33 at the moment. Click on next. And we're going to add those two files that we just created. Now I suspect we're going to have to iterate this a few times because normally the rotation of the components is incorrect. So first of all, the bill of materials file, which is this Excel file. The pick and place file, which is this XLS file. And then we'll click next. Hopefully now at this stage it should show all of the parts that we selected. If this table looks completely messed up, that means something went wrong in your export of the file. You know, if you've got an extra character somewhere in an extra column somewhere else, it just completely messes all this up. So now's the opportunity to check that all of the components are correct. So I'll quickly go through this. So I've just been through and all of these parts look correct. So I think our bill of materials is correct. We can now go through to the next page and it will start producing a preview of where all the components are going on the board. So at first glance it looks like we've got the positions all correct, but we need to check the polarity. So diode 1 is correct here. It looks like U1 has been incorrectly rotated, so that needs rotating clockwise 90 degrees. So U1 clockwise 90 degrees, that means we take away 90. So that should be that one corrected. We've got the capacitor that needs rotating anti-clockwise 90 degrees, so we need to add 90 to C1. And so on. So you just need to go through and check all of those parts are correct, which I'm going to do now. So there's only 6 changes there, so we'll go back and just redo the upload of those 2 files. We don't need to upload the Gerbers again. So we'll do the bill of materials, the pick and place. We know the bill of materials is correct because I've not changed anything here. And then we should see the orientation of these all corrected. Now they do check against the silkscreen marking, but it's always worth just trying to get it right in the first place, and then you don't have to worry about anything being changed. So that's been rotated. We've got the capacitor the correct way around. The LED is correct. We've got these diodes the right way around and the 2 regulators. So that's all correct. Yep. And it's coming out at $107 for those 20 PCBs. So that's not too bad at all. Let's add it to the cart. Along with all of the LED boards, I actually added some extra ones in there. So $204, that's for 20 of these assembled PCBs, excluding the DC jack, potentiometer and switch. And also for 20 of these panels. Now I've ordered extra ones because I think I might use these for some lab lights running at a higher power on a big heatsink. But there's enough there to make 20 full sets of ring lights. So if we divide that down, that's only $10 per set of PCBs, and we just need to buy the LEDs separately. So not too bad at all. I'll also include the files, these production files, in the description down below. So if you want to order these or whatever now, then you can do. And what I'm going to do is probably tomorrow is when I'll actually place the order for these. I'll just give my mind one day to rest and then just have another final look before I place the order. And then as soon as they come in, we'll do another video and see if it's all working. So hopefully you found the video useful. Until next time, thanks for watching.